All right, in our last video, we talked about mass spectrometry and the fact that most of the elements on the periodic table do have more than one naturally occurring isotope. And when we use that mass number on the periodic table, it's an average of all of those isotopes put together. Okay, now we're actually going to calculate that, which means that we're going to take, okay, if we take all these isotopes and put them together, what does that average atomic mass become? Okay, so we know that these atomic mass numbers on the periodic table are not integers. Remember, an integer is a whole number. Okay, so well, why aren't they integers? I mean, don't they have a specific number of protons and neutrons? Yes, they do. But again, let's talk about what it doesn't mean. Okay, for example, the atomic mass, and we talked about this the other day in the previous lesson, is the mass on the periodic table for chlorine. Again, you can kind of round it different ways, but basically it's 35.45. Okay, and a lot of times when we write that, we would just call that chlorine 35. Okay, now of course what that doesn't mean is it doesn't mean that there's 17 protons, 17 electrons, and 18.45 neutrons. Okay, obviously you can't have 0.45 neutrons. Okay, but that 0.45 must mean something. So why, instead of 35 or 37, why is it not? Is because, again, in the case of chlorine, there are two different isotopes of chlorine. There's the chlorine 35 isotope, and there's the chlorine 37 isotope. Okay, and there's just a real quick calculation we can do that determines the actual average of those two put together. Now, obviously, if it was 50% chlorine 35, so if you had 50% this one and 50% chlorine 37, well, then certainly what would be the average of those two? Well, of course, it'd be 36, okay, because it's 50-50. But if there's more of one than the other, like we saw yesterday with this question right here, if there's more than one than the other, then obviously that average is going to be more, in this case, weighted towards the 127. In this one right here, it'd be weighted more towards the 126. Okay, so only when it's 50-50 can you actually take the two masses and put the two of them together. So the way that we calculate that is we use this equation right here. Now, right below it, it does say, note, this formula is not given on the AP exam equation sheet, but you absolutely should know it, should be familiar with it. You absolutely need to know how to use it. Okay, now what is it? Let's talk about what this means. So first of all, let's go back to chlorine. So of all the naturally occurring chlorine that exists, and again, how do they know this? They use the mass spectrometer. The mass spectrometer tells them that of the chlorine, of this chlorine sample that you just put into this machine, about 75% of the chlorine atoms are chlorine 35 atoms. And about 25% of those chlorine atoms are chlorine 37, have a mass of 37, so they have two more neutrons. Okay, now if they give you the actual mass, like if they say chlorine 35 and then they say the mass is 34.9872, AMUs, atomic mass units, then you use that. If they don't give you the actual perfect mass, then you use whatever masses they give you. Okay, but if you're trying to decide, well, which mass do I use? Do I use the 35 from the chlorine? Because they might say 35 Cl and then mass, and they might say 34.9872. And that's measured in atomic mass units, AMUs. Which one would you use? Absolutely, you would use this one. Okay? If they don't, then you use 35. I mean, clearly 34.9872 is very close to it anyway. Okay, so what we're going to do is to get the average atomic mass is this symbol right here means the sum of, which means you're going to add them together. Which means you're going to take the percent of each isotope, so the 75%, the 25%, and you're going to multiply it by the atomic mass. So you're going to take 75% and you're going to times it by 35. And then you're going to add that, remember the sum, to 25% times its mass. Okay, so this equation would look something like this. You would go 75% times 37 plus 25% times 30. Did I do that wrong? 75 and 35, yeah. 25 and I just wrote it wrong, didn't I? You guys caught that. 35. 75 times 35 plus the sum of the 25% times its mass, 37. And then we're going to divide by 100. Now, I put percents in there. When you put it in the calculator, don't put the percent sign in there. Okay, and obviously this is just a math problem. So, well, wait a minute, Mr. Johnson. Isn't 75% just 0.75? Of course it is. Could I just use 0.75 and then not divide by 100 at the end? Absolutely yes. I don't really care how you do it. Neither do they on the AP test, okay? So I divide by 100 in this case because instead of changing the percent to a decimal, I just leave it at 75 and leave it at 25. Okay, and then I go to my calculator and I go 75, and again, do this on your calculator, please make sure we get the same answer. 75 times 35 plus 25 times 37, and before you hit divide here, hit equals, get an answer, so get a number. Remember, this is like a parentheses on the top in that order of operations. So hit equals, and now I'm going to divide by 100. Okay, and again, obviously I didn't use the real masses of chlorine, 35 and 37, but I got pretty darn close still. I got an answer of 35.5 atomic mass units. Okay, and that's, again, the periodic table I think is 35.45, so we're pretty close to that. Okay, example 1 here then. Here's an element that has, holy cow, 1, 2, 3, 4, 5, 6 different naturally occurring isotopes. Clearly this one right here is the most abundant one because it has a percentage of 34.28. That one's also the heaviest, which means it has the greatest number of neutrons. Again, we know nothing of it. The electrons are the same in all of them. Protons are the same in all of them. Only when it's an isotope do the neutrons change. Okay? And we could do the same thing we just did up there. So we would go 2.65, again, leaving it as a whole number, not a decimal. Again, do it how you want, though. Times 122 plus 4.84. Put my old man glasses on here. Times 124 plus 7.27 times 125. And obviously this is an extreme case. This usually isn't, you aren't doing this much. Plus 18.98 times 126 plus 31.94 times, not plus, times 128 plus 34.28 times 130. Take that whole thing, get an answer, hit equals, and then divide by 100. I did it earlier just so I wouldn't have to be typing in my calculator forever. And check your answer. Go ahead and pause now and check your answer with mine. I get a final answer of around 127.7 atomic mass units. Okay, example 2. Neon has 3 naturally occurring isotopes. So like neon signs, there's 3 naturally occurring isotopes of neon. There's neon 20, and it has a percent abundance of 90.48. There's neon 21, has a very low percent abundance of 0.27. Neon 22 is the 3rd naturally occurring isotope of neon. What is its percent abundance? And here's the key here, and one of your homework problems has a problem that's more challenging than this one about this. Okay, the key here is to know that if you don't know, in this case, there's 3 isotopes. Okay, remember that the percentages have to add up to 100%. That's the key here. Well, if we know 2 of them, and one of them's 90.48 and the other one's 0.27, I can just take 100 minus 90.48 minus 0.27. And that will give me an answer of 9.25%. So neon 22 has a percent abundance of 9.25%. Okay, in the homework problem that you're going to do, they don't give you either of the percentages, but they do give you the average atomic mass, and I think it might even deal with neon. Okay, I'm trying to remember exactly, but it doesn't really matter. Okay, what matters is when you're trying to figure out those percentages, let's say one of those percentages is X, because you don't know what it is, so what do you use? You use the letter X. Well, if one of the percentages is X, and there's only 2 isotopes, and in the problem it tells you there's only 2 isotopes, what must the other percentage be? Well, what did we do here? We took 100 and we subtracted whatever those values are. So if one of the percent abundances of one isotope, this is the first isotope, if that one has a percentage of X, what's the other isotope's percent going to be? Certainly it's going to be 100 minus X. So that percent is going to be for the second isotope. Now, obviously, if there's more than 2 isotopes, this whole thing here doesn't work. But in this case, it does, because there's only 2. So when you get to that homework problem, remember, look at the answers as well. I tried to explain it there as well, but maybe just by me explaining it out loud rather than words, it'll make more sense. Okay? All right, and now part B says calculate the average atomic mass of neon. Remember, one way to get the answer of the average atomic mass of neon is look at the periodic table. It's on the periodic table right now. Okay? I believe it's like 20.18 or something like that. Okay? So you could do that, and you can look at it and go, oh, well, it's 20.18. Obviously, they're not going to do that to you because they know that all the answers are on the periodic table. So let's go ahead and do the work, though. If this was an unknown element and you didn't know the answer, that's how they would do it. So 20 times 90.48. You guys are like, is his handwriting really this bad? Yes, it is. Don't judge me. And then 21 times 0.27. And then the final one is that neon 22. So we're going to take 22. And obviously, remember earlier I did the percentages first and then the masses, but here I'm doing them backwards. It doesn't matter. When you multiply, it doesn't matter. So then 22 times its percent, which we have right here, 9.25. And then we're going to divide by 100. Now, I want to verify, because again, I think it's 20.18. I want to make sure that is correct. So 20 times 90.48 plus 21 times 0.27 plus 22 times 9.25 equals, divide by 100, and I guess if we did the same, right around 20.18. I guess around it would be 20.19. Okay? And that's very, very close to what we see on the periodic table, so that is our correct answer.